PharmaPal.
You're listening to Bloomscast, the official podcast of Blooms.io, home of the bioactive library for mass spectrometry instant optimization. Let's dive into the latest in natural chemistry, bioactive discovery, and the future of lab innovation.
Mission for today: figure out what the science says about Anastatica Hierochuntica. Traditional uses, what's actually in it, and crucially, how it might affect us, especially based on research.
Sounds good. Where should we start? The traditional side.
Yeah, let's start there. What's the history?
Well, traditionally, it's played a pretty big role in folk medicine. You often hear about it being used to help with difficult childbirth or uterine bleeding.
Okay, childbirth makes sense given some of the names, but you said it goes beyond that.
Oh yeah, way beyond. The sources we looked at list a whole range of things.
Like what?
Let's see. Infertility, inflammation, pain relief, arthritis, diabetes, heart issues.
Wow.
Even things like depression, high blood pressure, headaches, problems with periods, boosting milk supply.
Okay, that's quite a list.
And also helping to expel the placenta after birth, or even in cases of pregnancy loss. It's really seen as quite versatile in traditional systems.
Sounds like a real go-to remedy. And it's still actively used in labor.
It seems so. Particularly in Malaysia, Senggol Fatima, as they call it there. Pregnant women apparently still use it, often near the end, hoping for an easier labor.
But you're saying the safety research has really kept up with that practice.
That's the catch. There's limited scientific backing, especially rigorous safety studies during pregnancy, despite this ongoing use.
So how do people typically prepare? Is it like a tea?
Mostly, yeah. You take the dried plant, which looks kind of like a closed-up fist,
Right.
and soak it in water. It absorbs the water and dramatically opens up or resurrects, which is part of its mystique.
Ah, the Rose of Jericho effect.
Exactly. And then you drink the water it's soaked in, the infusion. Or sometimes it's ground into a fine powder and consumed that way.
Okay, taken internally. So what did the science find inside the plant? What chemicals are we talking about?
Well, analyses of extracts, usually made with water or water and ethanol, have identified quite a few phytochemicals.
Okay.
Things like steroidal and triterpene glycosides, flavone glycosides, saponins, tannins, reducing compounds, and coumarins showed up.
Those are some complex names. Any key ones we should focus on?
Well, glycosides often have various biological activities, and things like flavonoids are well-known antioxidants. They did also specifically quantify the total phenolic compounds in flavonoids.
Using those equivalents you mentioned. Gallic acid and quercetin.
Exactly. GAE and QE. It's just a standard way for scientists to measure the amount of those types of compounds. Interestingly, they didn't find things like alkaloids or certain other types like cardenolides in the extracts they tested.
What about the powder form? Was that tested chemically?
The sources we reviewed mainly mentioned testing the powder for moisture content, not the full chemical profile like the extracts.
Got it. So we know some of the ingredients. What about what they actually do? Any proven effects?
Yes, several reported activities. Lab studies suggest it has anti-nociceptive properties.
Meaning pain relief.
Right. And anti-inflammatory effects, antioxidant activity, and even some cytotoxic activity against certain cancer cell lines in lab tests.
Cytotoxic, meaning it killed cancer cells in a dish.
Yeah, specifically HeLa and AMN3 cells mentioned in one source. Of course, that's very early stage lab work, a long way from treating cancer in people.
Sure, but interesting nonetheless.
Anything else? There was a mention that the water extract increased levels of something else in the body, but the details weren't specified in what we reviewed.
Okay, so some potential benefits hinted at, but let's get to the pregnancy aspect, given the traditional use. What about the prenatal safety studies? That seems critical.
Absolutely critical. And we have a couple of key animal studies here, mostly using rats, looking at the aqueous extract, AHAE.
Okay.
So one main study used Sprague Dolly rats. They divided pregnant rats into 4 groups, a control, and then 3 groups getting different daily doses of AHAE, 250, 500, or 1,000 milligrams per kilogram of body weight.
Milligram per kg, right?
Yeah. They gave it orally from day 6 to day 20 of gestation, then examined the mothers and fetuses on day 21.
And what happened to the mothers? Any effects on them?
Yes, definitely. The moms in the low-dose group, the 250 milligram and the high-dose group, 1,000 milligram kilograms, actually gained significantly less weight during pregnancy compared to the control group.
Less weight gain. Okay.
And the high-dose group also had significantly heavier livers.
Heavier livers, suggesting maybe some stress on the liver.
Essentially, yeah. But interestingly, their food and water intake didn't really change much.
Okay. So Effects on the moms at low and high doses. What about the fetuses? That's the big concern.
Right, and the effects there were pretty striking and a bit weird, actually.
Weird, how?
Well, fetal body weight was significantly lower in the high-dose group, the 1,000 milligram one for both males and females, but it was also lower for male fetuses in the lowest dose group, the 250 milligram.
Wait, so lower weight at the lowest dose and the highest dose, but not the middle one?
Exactly. And there were physical malformations, too.
But what?
One fetus in the high-dose group had a cleft lip, and one in the low-dose group was described as having short stature and no tail.
No tail. Wow.
And another high-dose fetus showed hydrocephalus water on the brain. These are pretty serious findings.
Definitely. You also mentioned something about anogenital distance, AGDI.
Yes, AGDI. It's a measurement scientists use in these studies as a marker for prenatal exposure to androgens, male hormones.
And what did they find with that?
It was significantly increased in fetuses from the high-dose group, both sexes, and also in male fetuses from the low-dose group.
Increased AGDI. Suggesting
a potential masculinizing effect during development, again, happening at the low and high doses.
So, masculinizing effects, physical defects, lower weight, but only at the low and high doses. What about the middle dose, the 500 kilograms?
And this is the really fascinating part, that middle group. They largely avoided these negative outcomes.
Really?
Yeah. In fact, that group actually showed a higher rate of embryo survival. They had a lower resorption index, meaning fewer implanted embryos were lost.
So the middle dose seemed protective, while the doses on either side caused problems.
Precisely. It's what researchers call a non-monotonous dose-response curve, NMDRC.
Non-monotonous, meaning not a straight line. More isn't simply worse.
Exactly. It's not like small dose, small effect, big dose, big effect. Here, small dose, bad effect. Yeah. Medium dose, maybe okay, or even good effect. Big dose, bad effect again. It complicates things significantly.
Hugely. Makes figuring out a safe dose incredibly difficult.
Absolutely. You can't just assume less is always safer.
Did the study suggest why this might be happening? Something about hormones.
They did propose a mechanism involving hormonal disruption. The idea is that certain flavonoids in the plant extract they mentioned, quercetin, naringenin, erydicycliol, might be acting as aromatase inhibitors.
Aromatase inhibitors. Remind me what that means again?
Aromatase is the enzyme that converts androgens, like testosterone, into estrogens. So if you inhibit it,
you could end up with more androgens and fewer estrogens.
Potentially, yes. And that imbalance during development could explain the masculinizing effects, the increased AGDI.
And maybe the weird dose response, like a small amount disrupts things, a medium amount maybe triggers some compensation, and a large amount just overwhelms the system.
That's the kind of complex biological interaction they suspect might be happening, leading to that NMDRC pattern.
Wow, okay. Now, there was another study you mentioned, focusing specifically on skeletal development.
Yes, same setup, basically Sprague dolly rats, same doses of AHAE, but really zooming in on the bones and cartilage of the fetuses. They used a special double staining technique to see bone and cartilage clearly.
And did they find similar issues?
They did, largely mirroring the first study's dose pattern. Problems were mainly seen in the 250 and 1,000 milligram groups.
What kind of skeletal problems?
Well, in the low-dose group, one fetus had sacropodogenesis, basically missing its lower spine and tailbones, plus other bone issues.
Missing tail again.
Right. And in the high-dose group, they again saw a fetus with a maxillary defect, that cleft lip finding.
Okay, so consistency on the cleft lip. Anything else?
Yeah. They also noted shortened limbs, forelimbs, and hind limbs in some high-dose fetuses and some pelvic bone abnormalities, specifically the ilium. And in the low-dose group, some fetuses had malformed pelvic bones, too.
So again, issues at 250 and 1,000 milligrams.
Yeah. Correct. Though they did note one common variation, incomplete bone formation in a skull bone called the interparietal, was seen across all groups, including the control. So that might just be a spontaneous thing in these rats, not necessarily caused by the extract.
Okay. But overall, this bone study reinforces the potential toxicity to development at the low and high doses.
Yes, it strongly supports that conclusion and the non-monotonous dose-response pattern. Again, the 500 millikilogram group seemed to have fewer marked skeletal issues.
Right. We talked a lot about the developing fetus. What about just general immediate toxicity, like if someone took a very large amount at once?
There was one study looking at acute oral toxicity in mice. They gave single high doses of both the water extract and a water ethanol extract.
Come on, Pink.
At 2,000 millikilogram, the mice showed symptoms like rapid breathing and drowsiness. The drowsiness seemed to last longer with the water-only extract.
Did they figure out a lethal dose in LD50?
They estimated it. For the water extract, it was around 5,000 kilograms, and for the water ethanol one, around 2,500 kilograms.
Okay, so fairly high doses needed for acute lethality in mice, it seems.
Relatively speaking, yes.
Now, going back to the traditional use for labor, did any science look at uterine contractions?
Yes, there were in vitro studies, meaning lab-based, using isolated mouse uterine tissue.
Not in live animals.
Correct, just the tissue in a lab setup. And they found that the water extract did cause the uterine muscle rings to contract.
Ah, so there's a plausible mechanism for the traditional use.
It seems so. Both the water extract and the water ethanol one induced contractions. The water ethanol one seemed a bit more potent. It had a stronger maximum effect and worked at a lower concentration.
More potent than the water extract.
Yes. But, importantly, neither was as potent as oxytocin.
Oxytocin being the hormone the body uses naturally and also given medically to induce labor.
Exactly. So the plant extract does cause contractions, but maybe not as powerfully as oxytocin itself.
Okay, let's try and wrap this up. We've got this plant, Anastatica, Hierochuntica, with a really rich traditional background, especially for women's health, childbirth.
Right, a long history there.
But the science, particularly these animal studies on prenatal development, paints a much more complicated picture, maybe even a worrying one.
I'd say complex and definitely warrants caution. The rat studies flagged potential safety issues with the water extract at both low and high doses. We saw reduced maternal weight gain, lower fetal weights.
Those signs of hormonal disruption, the masculinizing effects.
And actual birth defects like cleft lip, missing tails, skeletal issues. And the most complex part is that nonlinear dose response, where the middle dose tested seems safer, even maybe beneficial for embryo survival in rats.
Counterintuitive.
Very. And the skeletal study backed this up, showing bone malformations concentrated in the low and high dose groups.
But we did see the lab evidence that it can cause uterine contractions.
Yes, which aligns with the traditional use for easing labor, providing a potential scientific basis for that specific application, although perhaps less potent than oxytocin.
But the really big caveat here is,
these are primarily animal studies, mostly rats and mice. We have to be really careful about directly extrapolating these doses and specific effects to humans.
right, human biology can be very different.
Absolutely. So much more research is needed to understand the implications for people, especially pregnant women who might encounter this herb.
So when you put it all together, the centuries of traditional use on one hand, and this emerging, complex, sometimes concerning scientific evidence on the other, what does that tell us?
Well, for me, it really underscores how vital rigorous scientific investigation is, especially for natural remedies used during really sensitive times like pregnancy.
Yeah, tradition is valuable, but science can uncover risks or complexities that weren't obvious.
Exactly. It shows herbal medicine isn't always simple, effects aren't always linear, and we need to approach it with both respect for tradition and a critical scientific eye.
A really fascinating, if complex, picture.
Thanks for tuning in to Bloom's Cast, brought to you by blooms.io. Stay curious, stay connected, and we'll see you next time on the frontier of natural product innovation.
PharmaPal.